Ang susunod na programa ay rated G. Ito ay pwede sa lahat ng manonood. Ang susunod na programa ay rated PG. Patnubay at gabay ng magulang ay kailangan sa mga batang manonood. Ang programang ito ay rated SPG. Striktong patnubay at gabay ng magulang ang kailangan. Maaaring may masiselang tema, lengguwahe, karahasan, sexual, horror o droga na hindi angkop sa mga bata.
Good day, everyone! My name is Francis Jr.
And I am Robert Vergel Sabaliana. Today, we're going to talk about the topics of geometry. To start, the Pythagorean Theorem,
The golden section,
the golden rectangle.
and the regular polyhedra.
So let's start.
Yes.
Okay, so let's down to our first topic, which is the Pythagorean Theorem. So let's start with the person who really discovered the Pythagorean Theorem, which is Pythagoras. Pythagoras was probably the first person who gave a proof of the theorem. There are hundreds of proofs for the theorem of Pythagoras. Leonardo da Vinci and President Garfield are among those who contributed proofs to this famous theorem. To put the theorem of Pythagoras in algebraic form, which Pythagoras could not do, we give the measure of A and B to the legs of a right triangle, and the measure of C to the hypotenuse. Then, the Pythagorean theorem states that the square on the hypotenuse of a right triangle is equal to the sum of the square on the legs.
So our second topic is about the golden section. To obtain the golden section, we start with a line segment. We're going to divide this segment into a certain proportion. That is, we're going to attempt to locate a point P on the line segment RS, such that if the measure of the line segment RS in figure 7.3 is 1, and the measure of RP is D, then the measure of the line segment PS is 1 minus D. The proportion that is desired for the location of P is such that 1 over D is equal to D over 1 minus D. From this proportion, we find a quadratic equation. D squared plus D minus 1 is equal to 0, where our variable is D. And we can solve it by the application of the quadratic formula. And the quadratic formula is equal x is equal to negative b times plus minus the square root of b squared minus 4ac over 2a. For example, in our quadratic equation, d squared plus d minus 1 is equal to 0. The variable is d, and we let a is equal to 1, b is equal to 1, and c is equal to negative 1. By distributing it to the quadratic formula, d is equal to negative 1 plus minus the square root of 1 plus 4 over 2 is equal to negative 1 plus minus the square root of 5 over 2. Since we wish a positive value for d, we use the root d is equal to negative 1 plus the square root of 5 over 2. This gives the exact value of d, since the square root of 5 is approximately equal to 2.24, and we find d is approximately equal to 0.618.
Okay, so our third topic is all about golden rectangle. So to obtain the golden rectangle, first we draw a square whose sides have a measure of 2 units. Next, we connect the midpoint of one side of the square with an opposite vertex. We can find the measure of the line segment CE, which is we can refer to figure 7.4 by the use of Pythagorean Theorem. Okay, so the value of CE squared is equal to 1 squared plus 2 squared. Again, it is equal to 1 plus 4, which is equal to 5. So now, the value of CE is equal to square root of 5. Using point E as the center of line segment CE, as a radius we draw an arc of a circle which cuts line AB at point G. The measure of line segment EG equals to square root of 5 because it is a radius of our circle. Then, rectangle AGHD is a geometric figure with the divide proportion. The ratio of the width of this rectangle to its length is, so we can use the formula which is width over length. Okay, so let's start. 2 over 1 plus square root of 5 is equal to 2 over 1 plus 2.24, which is equal to 2 over 3.24, and it results to 0.618.
So our last topic is about the regular polyhedra. A polyhedron is a geometric solid made up of certain number of faces, edges, and vertices. In a regular polyhedron, the faces are portions of planes bounded by regular polygons of the same size and shape. The faces meet by pairs in line segments is called edges, and the edges meet in points is called vertices. An example of regular polyhedron is a cube. Its faces are squares. And the Greeks proved that there are only 5 regular polyhedra: the tetrahedron, hexahedron, octahedron, dodecahedron, and icosahedron. The regular polyhedra satisfies Euler's formula, which is true for any polyhedron. Euler's formula states that the number of faces plus the number of vertices is equal to the number of edges of any polyhedron plus 2. So let's now check the truth of the Euler's formula for the octahedron. The octahedron has 8 faces. Since each face has 3 sides and each edge of the octahedron is in 2 faces, so let's now find the edges. So we can find it by 3 times the face over 2 is equal to 3 times 8 over 2 is equal to 12. We also know that 4 faces meet at each vertex. So therefore, we can find the number of the vertex. So this is equal to 3 times f over 4, which is equal to 3 times 8 over 4, which is equal to 6. So now, let's substitute these values in Euler's formula, and we can have the number of faces, which is 8, plus the number of vertices, which is 6, is equal to the number of the edges, which is 12 plus 2. So 8 plus 6 is equal to 12 plus 2, which is 14, is equal to 14.
Okay, that's it. So we hope that you really learned something about the topics of geometry, about the Pythagorean theorem, the golden section, the golden rectangle, and the regular polyhedra.
So if you really like our videos, just visit our website www.naisaro.com.
Thank you.
Thank you, bye-bye.